So let me invite here on the stage our next speaker. It's a solution architect at EPAM, Istvan Nagy. Istvan, hello, welcome to Java On Conference.
Hello, everyone. It's a pleasure being here, and thanks for introducing me, Roma.
Sure, it's a pleasure to have you on our conference. So, I already told our audience the name of your talk, and I was tempted to keep it secret, more or less. So, can you give us some hints what your talk would be about?
Yes, of course we will be talking about secrets, but I know the title is about keeping them, but I will share them, or at least some of them during the talk. And the whole point would be what are secrets in general when we are interacting with them as engineers, primarily because I'm an engineer, so I would like to talk about that part. And of course, how we can keep these secrets in a safe way so that we are not messing anything up. And you should listen to the talk for the rest.
Okay. I do hope we will learn more about that. So, guys, I think we can start with the talk mostly already. A small reminder that you can leave your questions for our speakers in the chat on YouTube and in the chats on VR community platform. I'm looking in all the chats and try to collect all your questions. So please take this opportunity to ask your questions and receive valuable answers, which will help you in your future work life and whatever. So I think we can start. Istvan, good luck. Stage is yours. Let's go.
Thank you very much. And yeah, just for the record, so I'm Istvan Nagy, and I would like to share some secrets with you, as we have just discussed. This will be, I hope, a very interesting presentation for kind of everyone, but I will hear from you in the end. So I hope you will enjoy it as much as I do. Starting with a bit of an introduction, because I suspect that most of you never heard about me, and that's okay. It was a secret after all. So regarding my experience, I have more than 15 years of experience, of course, combined from software engineering, solution architecture, and basically everything in IT. The last 12 years plus a couple of months with EPAM, of course. And regarding my tech stack, so I started as a Java backend developer, and I've done it for many years, and I still feel like a backend developer in a way. So of course, during this time, I have worked with Java, Spring Boot, anything that is fancy, and I had some great opportunities to use AWS services or Azure, which is very good. I kind of like the cloud because it is a very big playground, and it's a good thing to learn because besides AI, this is a hot topic still. Um, yes, and regarding my hobby, so I mentioned that I'm an open source developer. As you might imagine, this is taking most of my time, so I don't need any other hobbies. That's already a win. I don't need to decide too often what to do. And yeah, so regarding today, I have prepared with a content slide so that you can figure out what we are talking about. The good news is that we are halfway there. So we have already covered half of the slides, or sort of. We just have to cover the main topic. And of course, there will be an opportunity for Q&A in the end. But let's talk about the main topic then. So what are these secrets which we are talking about? And I would assume that everyone has some kind of an understanding about secrets. So if I asked you what are secrets, if you are older than 4, then probably you have an idea about that. And you would tell me something, but it wouldn't be necessarily exactly the same from everyone. And that's all right as well. So I wanted to start with the baseline. So I went for a dictionary definition from Cambridge Dictionary in this case. And it says that a secret is essentially a piece of information that is only known by one person or a few people and should not be told to others. And this has everything in it. That's why I picked this definition, because it's great. So it tells us that A, it is an information. Also, it says that there is a limited group of people, so not a lot of people know this, and we don't want to add any more people to the group. So that's how we keep secrets, right? But without revealing much about the talk, I suspect that you are already rethinking your choices, and you suspect that this has nothing to do with software engineering, and you are right about that. So I have prepared, and I have brought you a bit of um, a description from the software engineer's point of view as well. From a point of view of a software engineer, I think we have kind of two kinds of secrets we can talk about. The first one is company secrets, which are anything that's important for our company and they don't want us to share, basically. So some confidential information about the processes we are using, or clients, the company's financials, any upcoming releases, any major things, anything that moves the needle on the stock market. So anything that's material, basically, uh, and anything that falls in scope of an NDA, for example. So these are the secrets, and there is one common thing we can conclude about all of these, is that these must be protected because we can get in trouble if leaked. So that's kind of the bottom line there. And regarding the other category, which is, in my opinion, way more interesting to an engineer, are application secrets. And these are similar. So still we are talking about confidential information, but this is not needed by people. So this is not something you would hear at the water cooler if you go for a break. But this is something that is needed by your application to function, uh, to be able to develop that application, to be able to test that, to deploy that. So something like credential, or like any kind of connection details, or a certificate, anything like that. So anything that is not something you would put out in the open, but it is still needed by the application to be able to function. And of course, there is one aspect which is common. So we must protect these because we can get in trouble if they are leaked. But there is a way more interesting part, that we shouldn't know them in the first place. And why would I say that? Well, unfortunately, I have some news for you. So I have spent less than 5 minutes on Googling some high profile cases when someone messed up and they committed something into Git and they shouldn't have. And as a result, a couple of terabytes or a couple of million secrets, or some data was leaked because of this simple mistake. So this is why I say that we shouldn't know these secrets, because we are terrible at keeping them. So probably it's not a good idea for us to know them in the first place, because then we tend to commit them into the code. But okay, of course you wouldn't do that. So let me give you some stats. During the course of last year, so 2023, there were almost 13 million secrets which were identified on GitHub alone. And GitHub is big, but it's only one site. So there is GitLab or Bitbucket or whatever. They are not alone. Imagine how many secrets are there as well, and what kind of problems this might cause, because this can have real life consequences. I suspect that none of these big companies were happy when these issues were discovered. Probably the stock market didn't go up very high either. So these are big issues, and they might impact their users. Identity theft is not a joke, really. So we need to make every effort to avoid these situations, and that's why I say you shouldn't know these secrets in the first place. Okay, so moving on. I suspect that it's not really trivial to think that, okay, this has something to do with you, or to imagine how this changes your daily workflow. So I have brought an illustration, starting with you. And of course, you have an application, so you are working on that. And this application is used through a gateway, so there is another component. and the application is connecting to a database, because those are the really interesting applications which have a database. As a backend guy, I can relate to that. So that's why I brought this example. But the first question comes to mind when I look at this diagram that, okay, but the database is using some strong authentication for sure. Where should I put the secrets which are used? I mean, the credentials or connection details, for example. So the secrets which are used to connect to the database. Of course, I couldn't put it in Git because we have discussed that that's the sure way to get into the news, and I don't want that. So probably I need to figure out a better way. And lucky for me, a lot of people thought about the same, and they are way smarter than me. So they have figured out that we need some kind of a safe place, some vault or something. We can call them secrets managers, where we can put these secrets, and then we don't need to worry about anything because the secrets are safe in this secrets manager, and the application can connect to that, then fetch the secret and connect to the database in a safe manner, and all good, right? Well, not exactly, because those who are still awake might ask, okay, but how do you connect to the secrets manager then? Do we need a second secrets manager where we can put the first secrets manager's credentials? Of course not, because we would run out of space and we would just have endless chains of secrets managers without any benefit. So, of course, this is not a good solution. And that's why there are way better ones. So if we are talking about a cloud native solution, for example, then every cloud offering offers some kind of a solution to fetch credentials in a safe way. These are called managed identity. And the way they work usually is that there is a way for the application to connect to an endpoint, which is only available to that application, grab a token. The token is a proper JWT. There are roles assigned to that token. The secrets manager knows how to read that. It identifies the necessary roles, and if it sees the right one and it trusts the token, then it can say, okay, this is a good application. I want to give the secrets then because it's safe. And that's how they work in general. But some of the cloud providers are doing a bit more. So they offer multiple solutions to the same thing. So for example, in case of Azure, I want to give you a comparison. So when you are using managed identity in Azure, it might be a system assigned managed identity, which comes with your resource. So when you create like an app service application, then it has already a system assigned managed identity assigned. And the system assigned managed identity lives together with the application. They share the same lifecycle. It is only applicable to that resource. So this is perfect for that resource, but nothing else. And if you are thinking about sharing, you might need a different kind, which is called user assigned managed identity, where the managed identity itself is a resource on its own right, and it is having a life cycle, and you can share that managed identity among a lot of resources. So if you have a lot of resources, probably it's a good idea to just set up the user assigned managed identity once and assign it to everything, and that's all good. So that's one way to use it. And this is how it works in Azure, but other cloud providers might do differently. So your mileage may vary. But back to the diagram. So we have solved everything because we know that there is managed identity and it saves our bacon, so we can connect to the database in a safe way, right? Well, not that fast, because I have told you at the beginning that we shouldn't know the secrets in the first place. So who will put the secrets in the secrets manager, or how will you put that secret in the secrets manager rather? And well, the answer is you don't, because you can ask your favorite infrastructure as code solution, which you are for sure already using because it's a great thing, to generate the secrets and put it into the secrets manager. How, you might ask? Well, I have a generic workflow. Again, Depends on what the actual tool is, but in general, it is how it is working. So we can generate the random credentials, we can provision the database, then we can create the user with the credentials, I mean the database user, then we can provision the key vault itself and store the credentials afterwards. And if you notice, there is not a bubble in this whole diagram that would say, and share it with the developer because that's such a good idea, right? So this is why we shouldn't know the secrets, because the infrastructure as code handles everything for us. All good. Yeah, but this might mean some changes for our daily life. So uh, what should I do differently when I'm developing this application, considering that I use this whole new thing in the cloud? That's a very fair question, and I have two answers already. So the first one is that we can just trust Kubernetes that it will take care of everything for us. So, for example, in Azure, this is supported, but again, it depends on your cloud provider. So, in case of the Azure Kubernetes, you can just ask the Kubernetes resource to please go to the Azure Key Vault, grab the secret for me, and provide it to my application. And it is happening the same way as you can externalize your application configuration. So you don't need to worry about the thing because you can do the same locally. So you might set up a file in your local development environment that contains all the local configuration values, or you can provide environmental variables or whatever your framework supports, and you don't need to worry about the thing. It is just like yesterday before you realize that you need to use secrets managers. And that's a good thing. Unfortunately, it has some shortcomings. So there is one that the secrets are resolved during startup time. So if they are regularly rotated, for example, as everyone should, looking at you specifically, so if you are doing the right thing and you are rotating your secrets, then you need to always restart your instances to pick up that change. And it's not really a convenient thing to do that. So probably that's a big problem for us. Also, because of the way this works, so this can only support secrets and certificates, uh, even in case of Azure, where Azure Key Vault supports secrets, certificates, and keys. And you cannot really use the keys part because that needs constant communication between your application and the key vault, because the key vault contains the cryptographic key, and you are just asking it to please encrypt this, decrypt this, do something for me, that kind of thing. So you cannot just ask it to please give me the key itself, because it wouldn't work that way. So to work around this whole problem, which we have created in the previous solution, there is a different way, of course. So we can resolve the secrets in our application instead, which means that we are integrating with the SDK, and then we tell that custom code, which we are putting in our application, to please regularly go to the secrets manager and grab the latest secret. And if it changed, reinitialize everything, and it can work runtime. So basically, we have no problems whatsoever because the application configuration is updated in runtime. We can use the key use cases for cryptography. Everything works all right, right? Well, again, there is a con. We have a new dependency, and we need to run that dependency somehow locally when we are running the application, or connect to it or something. But just thinking about my friends and colleagues, so probably none of them would say, okay, this is my best day ever because I need to connect to a cloud native service every time I want to start or test my application locally. I hope I will need VPN too, because it's really not a good experience to do that. So of course nobody would want to do that. And I'm not picking on Azure Key Vault. It is just one of the examples, but any cloud native secrets manager could be written where Azure Key Vault is. Azure Key Vault is simply my favorite. And that's why I'm using that in my examples. But to be honest, I have never told you that we need to actually connect to the cloud native thing from local, because there is another way. We can actually run it locally. So how can we do that? Let's ask Stack Overflow. When I faced this challenge for the first time, I went just like we are discussing to Stack Overflow, and I found this question, which is the perfect question. So it is asking exactly what I needed. How can I run Azure Key Vault locally? That's exactly what I need. And the answer was not that positive, to be honest. So first, it told me that, duh, it has Azure in the name, so why would you want to run it locally? There is no way to do that. And you can do some extra work and circumvent somehow this mechanism that is reaching out to Azure Key Vault, and you can just acquire the credentials in a different way when you are running it locally or on test. And that was disheartening. So let me elaborate a bit on what my problem was. So what did it say? It said either connect to the cloud service, which I didn't want to do because that's why I went to Stack Overflow in the first place. So I thought maybe I need my money back. Or the other option is I can implement some kind of a horrible hack to circumvent the code accessing that cloud native service. And I have three major problems with that. The first one is that I'm using a completely different set of code for running locally and in my tests than running it on production, which is never a good idea. This is how you are introducing bugs on production, one of the ways. Or the other thing is that I need to ship some extra code that is meant to be test code, but actually I'm shipping it with my production code because I need the same horrible hack to be able to run the real application locally. And to be able to run the real application locally with this hack, I need to introduce it in the production code. And this might even come with some dependencies. And I don't know about you, but I have plenty code in my application, so I don't want to add anything more. I'm perfectly happy with just what I have. So I don't want to do this either. And the third thing is if I follow this advice and if I test the real Azure Key Vault integration only when it is really deployed and not on CI and not on the local test runs, then I'm testing Azure Key Vault integration only late in the process, which means that as simple as it gets, if Renovate creates, for example, a pull request for my application saying that, okay, there is this new SDK version released, you should integrate it. When I test it on CI, it says exactly nothing about that code because it is not used at all. So I can just choose and merge it and hope for the best, or I can never merge the new SDK and maybe face consequences as a result for that. So I'm not happy about this, and I realized at this point that there is only one logical step. So I need to write my local test double in order to work around this whole problem. I just needed to find out how to do that. So first, I think it looks like a good idea to figure out what kind of test double do we need in the first place. So the first kind everyone knows is mock. When you are using a mock, then you are setting up some expectations, then you are using that mock, and then you are verifying the behavior, which is not really what I want. I just want my application to be able to run locally. I don't want to fidget with expectations. I don't want to verify any behavior. I just want to see it work. So this doesn't really sound like what I need. Okay, I can use a stub, which can provide canned responses and then verify state, which is again not exactly fitting my needs, because even if I can somehow manage to solve the secrets part, I mean, something that provides a certificate or something that provides some connection details with these canned responses, one of the reasons why I went this way and not the Kubernetes way is that I can use the key part as well from the key vault. So cryptography, how can you that? How can you predict what any kind of encryption or decryption will result in? So it's not really working. But there is a third way, which is looking pretty promising. So if you look at this fake objecting, what does it say? It says it is a working implementation, exactly what I want, and it is not suitable for production use, which is exactly what I want. I don't care about this shortcoming at all, because I have a service already in production. I just need it to be workable for local use. So that's why I think we should build that beautiful wooden horse and ride it like a real one. So how did I implement my fake object? Well, I focused on three things. First, functionality, then compatibility, and then ease of use. Regarding the functionality part, so in order to implement the full set of secrets API endpoints, I needed to implement 12 API endpoints. And, it's kind of okay. It's not a big deal. Then for the keys, I needed 23 API endpoints, and they provide some support to three different kinds of keys. So RSA, EC, and AAS, and I needed to implement all three. So keys are covered as well. But there are certificates as well. So I needed to implement 17 additional API endpoints. Of course, these functionalities are already using the previous two. So if you are using certificates in Azure Key Vault, you are actually using keys and secrets as well, because a certificate is, simply put, a bunch of text which is signed cryptographically. So that's why you are storing it as a secret in a text format as well, and you are using a key to sign it. So that's how it works, sort of. And this is only supporting self-signed certificates. So this is one of the simplifications which I took to make it workable in this local environment. But it's not an issue, because self-signed certificates are pretty good for such a test case. Okay, so regarding the compatibility, when I started, there was only one API version, 7.2, and then each year a new one was released roughly. So we are at now 4 different API versions which are supported. And of course, there are other things. So I heard that there are other languages in Java. So I needed to implement some kind of support for all of these clients in Java, JavaScript, Go, .NET, and Python. And I actually wondered, are there any differences between them? I mean, how can I use them? How can I see it work? And I created some small Hello World-like projects to do that. And it was a very good experience, because it helped me realize that although these are all generated in a way by Microsoft, they are slightly different in some aspects. So there are some small differences which need to be considered when I'm implementing the server side of the whole thing. And that was a very eye-opening thing. Regarding the ease of use, so the whole goal was to have no extra code or dependencies to be able to use this whole thing, because that's what I said. I have plenty code in my application. I don't want anything else. And that's fair. Also, since we are using an HTTPS connection to the key vault, so it's only fair to provide a way to use your own certificates for that SSL connection, and then you can do it a bit more safe and easy way. You don't need to fidget that much with your self-signed certificates as a result. Also, I think since I realized that there are small differences between the clients, why not provide those Hello World projects as examples for each of the client? So I did just that. Then I realized that multiple vaults are a good idea in the same container, because we are in a testing mode. So this helps a lot with test isolation if we allow this. So I added that support as well. Then I realized that I'm tired of setting up my tests every time and initializing generating new keys and certificates, it takes some time and effort. Why not import the whole content and then it's all good? So I did import export support because that's a good quality of life thing. And while I was there, I implemented time travel because I could. Uh, it sounds a lot better than it is actually, but the thing is that when you are working with these keys, especially in the Azure keyword, so there are some ways which are used to rotate these keys or rotate your certificates and do some changes regularly. And it is very hard to test that. So if you are just setting up a new key, then it will be 0 days old. I'm sure you wouldn't want to wait like 90 days or 180 days in your test to let it rotate. So I wanted to give some control over that, and that's why I added an endpoint which you can use with a simple REST call to simulate the passing of time, and then the keyword will fake the rest. So this is what it is. And with this, I think it's time for us to put together some kind of a proof of concept application to test the theory and see how this whole thing works. So I have generated a Spring Boot app, which is kind of a hello world again, but it is using the official Spring Cloud Azure starter for the secrets. And it is using the JDBC starter because in the original diagram, which we have seen at the beginning of the presentation, so there was a database. So we will be using a database as well, and we will be working on securing those database credentials. So in the real service, when we are deploying this in production, I mean, who would deploy a hello world, but still we can. So we would use a real Azure keyword. In case of the local use case, we can use my local testable called low keyword, which is a drop-in replacement in this case. And we, of course, have a database, just like we discussed. I picked MySQL because that was easiest to start, but anything could be there. We just needed something that has some kind of credential, and this was a perfect choice for that. So no worries. If you are using a different database, you can use that as well. It's okay. This is just a generic scenario. So how do we do this? Well, I said we are not using anything new in the code. So there is a bit of a cheating moment. So I need some configuration changes. And to do that, I need to add a couple of system properties which are setting up the trust store so that the self-signed certificates, which low keyword is using, so those certificates are trusted by Java. This is okay if you are using your own trust store and your own certificates. You don't need to do this. Also, I need to add two environment variables because there is an automated authentication mechanism, of course, in the SDK. So if I want to do it in a clean way without any magic on the code side, so I need to confuse the SDK enough to think that it is actually connecting to the managed identity token endpoint, and it grabs the token, provides it to the local testable, which will then ignore it and provide the response. So this is just setting the token endpoint, and the other one is a technicality to confuse the client. But that client will grab a dummy token, which is not even a real JWT, and it will be just put in the header so that the local keyword can ignore it, really. This is, by the way, needed for the boot run task and the test task as well, if you are writing some tests, as you should. Moving on. So we have some production configuration as well. This is not because of the testable. So this is needed either way. If you are connecting to the real Azure keyword, you need exactly same configuration. This is just configuring the endpoint where the keyword is. This is a fake one, of course. The refresh interval, like we are checking every 10 seconds, and the names of the secrets which we want to grab from the key vault whenever that refresh interval is up, and the service version, which is the latest at the moment. So this is it, nothing fancy here. For the tests and the local execution to work, I have created a new profile, the dev profile, where we just need to override two things. One is turning off a security feature, which is not making a lot of sense in this context. So we shouldn't use that on the local machine because it is just enforcing a challenge basically to match the URL, and that's not really possible with localhost, while the other one is setting the endpoint to localhost. So that's it. Also, we need to start our own testable. So this is how we do it. Just grabbing a image, setting two ports, making sure that there is an import file shared on a volume, and setting some environment variable with all the application configuration in it. By the way, this is in the examples. So if you want to implement anything, you can just go there, see how I do, and modify it to your needs. So this is a small thing for the local execution port. Of course, we need to start our database as well. So in the exact same Docker Compose, we can start up MySQL, where we are setting a very secure password. I know I said we are not writing any passwords on Git, but this is different. So in my opinion, this is not really a secret, because what are we doing here? We are grabbing a Docker image of MySQL from the safety of the internet, then starting it up and providing a password to access the empty database. So everyone knows that there is nothing in this database, and especially nothing to steal. Anything that will ever exist in the database is already written in the test code in the Java files. So I think we are safe on that aspect. We don't need to worry about leaking anything here because we are not putting anything in this database in the first place. And that's why this throwaway database can be secured with this made-up key. Okay, so moving on. We have, of course, an import file, which is there for the low-key vault itself. I just created this slide to show that it really fits on one slide, but I know it's really hard to read. So let's take a better look. So this is one secret from the four, because we have a URL, a driver class name, a username, and a password. And if you look at this one example, so this is the URL one. You can tell by the name and the entity ID, and the value, of course, is telling as well, because that's a JDBC MySQL connection URL. Everything else is just some metadata, some administrative stuff. This is kind of how the API looks like in case of the key vault as well. I mean, the real key vault. So we are just saving a bunch of extra information so that we are doing it authentically. And as I mentioned, it is perfectly safe to store the fake password here as well, because we are talking about a throwaway database. No need to protect the empty database in any way. And I want to highlight two things. So in the created and updated properties, so there is a weird thing to write now. This is because this is a handlebars template, and the now 0 means that we should put the current time at the time of importing this into the created and updated timestamps. And why is it important? It is important because of the time travel, because just like I did now 0, I could say, okay, when you import this, make sure that it is 1 year old or 2 years old or whatever, how old. It doesn't really matter. The only thing why this matters is that you have perfect control even over the age of these secrets and credentials and keys, and you can simulate the rotations the same way in every test run. So your baseline will be truly exactly the same at every moment or every test execution. So this is how we do. But there is an important question. Does it work? Well, I brought you a picture because I often get picture or it didn't happen. So that's why I brought as a proof that when I executed this example project, it was working just fine. The context loaded without issues, so the tests passed. And of course, you don't need to trust me since it's a security talk anyway. So trust is something we need to earn. You can actually go to the example which I shared on my GitHub as a public repository and see for yourself that it is actually regularly tested and kept up to date with the latest dependencies as well. So you can just see my CI runs and see that it is working regularly. Okay, but what did we learn as a result of this whole exercise? Well, I hope we learned that we need to test exactly what we are using in production because it's an important thing. If we are not doing that, then why test at all? Is it okay if it will work everywhere except production? Of course not. That's why we are doing the whole charade. Also, the other thing is I hope that I raised the topic of the secrets management, and you are aware that we need to do absolutely better in this regard when we are handling application secrets, and under no circumstances put them in Git because that's how we leak them, and we should avoid that. Also, the third thing, which is equally important, is that depending on a cloud native service like Azure Key Vault or AWS Secret Manager is not the end of the world. You can just use a local test demo if one exists and go with that. Run it locally that way, and you can test the real thing when you are deploying to a real environment. Until that, the test demo will just do fine. I have also mentioned HashiCorp Vault here because many of the projects can depend on that as well, but it is not a cloud native thing. So in that case, you are in luck because you can run the real deal locally as well as a Docker container. So that's a pretty neat feature as well. Okay. Also, I have collected a bunch of references for you. So the first thing is the project home. So if you are interested in low-key Vault and my testable, you can check it out there. It is MIT licensed. You can do whatever we did. You can use it in your production code just fine. If you run into any issues, tell me, open an issue, anything. I'm really keen on getting feedback. Also, I have shared the example project which we were going through this whole presentation. So that's the second link. Also, I wanted to mention Git Guardian, which is a very good free tool where you can just register, configure it on your GitHub, and it can regularly go there and check your commits and pull requests. And it can say that, okay, it seems like you have committed something that looks like a secret. Are you sure about this? And it can even give you some recommendations how to handle these leaked secrets. So rotate them, create a new one, don't put it in Git again, any kind of tips like that. Also, I wanted to link the Azure Key Vault, the real service here, if you wanted to check it out. And since we were talking about managed identities, this is a good overview about them in case of Azure, so Entra ID managed identities. Please feel free to read it and learn more. Also, I wanted to give a shout out to Spring Boot because it's a great project. I really love using it, and it made it very easy for me to just go there to the initializer, click together this Hello World project, even including the Azure dependencies, download it, configure just what I have shared in the presentation, and everything just works. And also, in case you have heard about other test doubles, other than mocks on this presentation, then you should absolutely read this great article from Martin Fowler. which is an eye opener in this case. It introduces you to the different types wonderfully. And with that, I'm listening to your questions if you have any.
First of all, thank you very much for such a great talk. I can say that really important topic. For last couple of years, I work on a project where we work a lot with different secrets. I mean, keys, secrets, JWT token, etc., etc., etc. And I can say that this topic is quite underestimated. So
Yes,
thank you.
thank you.
So yeah, thank you very much for your talk. Yeah, we do have some questions. So sorry, first one, Istvan, thank you. Sorry. Yeah, so
No
November.
problem.
So Istvan, thank you. Do you plan to extend your project to cover other Azure services, as for example, local stack does with AWS?
Yeah, that would be a good goal. Unfortunately, it's a lot of work. So just keeping the Azure Key Vault functionality alive takes a lot of time as well. So it needs a lot of updates and making sure that everything works and reacting to issues. So I don't think I would start just yet and implement any other emulators. Also, I'm sure that there are already some. So for the most essential services, like I think Storage Blob, there is Azurite. For the Cosmos, there is a Cosmos DB emulator which you can use. So that's pretty good already. So I don't want to step on toes in that regard either. But I'm aware of the local stack project. It was one of the inspirations. So I really like that. I think as a one-man show, I'm not ready to start just yet. But if there are other developers and someone is willing to start, implementing something like that, I'm up for a good collaboration, and we can use slow keyboards as the keyboard part.
So yeah, guys, if you want to join Istvan in this journey, feel free to ping him, and I'm pretty sure that you could do something really amazing. Okay, moving forward, question from Andrei. When writing secrets for application that opens multiple DB connections, won't you run into a risk of locking the user during the time when password in DB might be different from the password that the application has read from Vault?
Yeah, that's a good question. So this is like a classic. This might happen just like the same way if you are going the other way. So if you trust Kubernetes to resolve these secrets for you, then you would have the same problem because the old instances are constantly connecting to the DB, and you might run into the same problem. So there is no easy way to solve this. I think the best you can do is make sure that you are using a sensible approach and you are not pinging the database too frequently to avoid these lockouts. But yeah, it's a tough thing to make a lot of changes at the same time, like update the real credentials in the database, make sure that every user is updated at the same time. Maybe you can solve this issue if you are creating two sets of credentials, like one user which is used in the old setting, create a completely new user which is using the new credentials. So both are working at the same time. And when it is saved, delete the old one. And then you don't need to run around unlocking things. So that would be one of the recommendations. Use two sets of credentials, and then you don't need to face this big issue.
Yeah, thank you for the answer. We have, well, it's a more comment, I would say, than a question. So let's read it together, and maybe we can check it together. Uh, I will post it in our private chat on the platform where we're streaming, so you can read it by yourself. And meanwhile, I will read it out loud. So our listener Sergey is amazed by the effort you put to this Vault service emulation, but still, how does this increase our trust in the application ability to retrieve secrets from the real Vault in real deployment? The code behavior is highly influenced by the configuration. So if you want to make sure, you must connect to real server using real configuration. And for that, you hopefully have a pre-prod environment and prod post-deployment smoke tests. And if we do not really test a thing locally or in integration component tests, why not using just static credentials for local development and testing? Also, setting up fake secret server is a pain in GitLab runners and such. I have a feeling that your approach is extremely useful for very specific cases, like time traveling with secrets, but on ordinary tests, this is an overkill. So, what do you think about that?
Yeah, first of all, thank you for the feedback. It's really good to hear from the users. I think the first part, because it's a big comment, so let's put it into different pieces. So the first part, that how is this improving the trust, and how can we make sure that the real connection will be successful as well if the fake connection was working, is kind of easy, because what are we changing? If you think back at my slide, so the only change which I did is turning off the challenge resource verification and changing the URL. Changing the URL is pretty sure tested in the real SDK, because no two keywords have the same URL, so it's kind of okay. Also, the authentication part is tested as well. So you can be sure that these minor configuration changes will not introduce any big issues. Uh, if you have managed to connect to your real key vault once with your code, then it will work the next time as well. You just need to run the tests with the fake one, and it will be okay. So if anything big comes up and something breaks with the fake one, then probably that indicates that something is wrong with your connection really, and the real one would have some issues as well. So that's the first part. Regarding the other one, I mean, using some static credentials and use that for local execution instead of using the local server, that's a valid approach as well. So if you are happy with changing your code and your configuration and managing this extra complexity, it's your right. You can do that. You should use what you can in order to be able to have the most confidence about your code that it will run perfectly on production. That's the only goal. We are doing the whole testing just for that. So if you can do that without using this local testable, then go for it. That's fine by me.
Yeah, sorry. To build some bridge for tomorrow, so tomorrow we'll have Anna Cherneshova from Test Containers at Docker, and we'll speak about that. So, question with a bridge to tomorrow: why not use test containers? Because I just checked, there is Vault test container, so it could be spinned up, and we just can connect to it.
Yeah, you can spin up vaults, but that's a different service. I mean, that's using a different API, so you need a vault connector. So you need the HashiCorp Vault in production as well, and that is good, although it is a software solution. And the real Azure Key Vault is using hardware-based security, so there is a very expensive piece of hardware behind every vault in the Microsoft Cloud. Actually, you can select software mode for your tests to make it cheaper. But anyway, and you don't need to buy this very expensive hardware piece, because Microsoft is just giving you the functionality in this managed service. So I think it has some advantages as a result, because this HSM is a really good thing. So if you want to use the cloud native solution that's recommended by Microsoft as well, then you can just use this test depot. And actually, there is test container module included. So I have implemented that as well. You can just use test container with this one too.
Yep, yep. Thanks a lot. And if you want to know more about test containers, if by some chance you are not using them right now, so join us tomorrow for the talk from Anna Cherneshova, and you will learn more. So let me. Yeah, sorry. I'm speaking too much. Looks like. So I think we can wrap up on that. So Istvan, I want to say thank you one more time for your really great, insightful talk. Thank you for being with us. It was a pleasure to have you on our conference, and hope to see you in the future. Thank you very much.
Yeah, thank you very much for this great opportunity. It was a pleasure. And guys, enjoy the conference.
Thank you. Bye bye.
Thank you. Bye.